This is the part C of exercise 6. So this is the last part of this exercise. This is the final exercise in this section on polynomials and zeros of polynomials. And so once again, we're going to put together a polynomial. This is a challenging problem. This is quite a bit more difficult than the others, so just be aware of that. I'll take my time as I go through and hopefully make it help you see that it's really not so bad if we just take it step by step. So we want to set up a polynomial having -1 as a zero of multiplicity 2, and we want 1 plus 2y to also be a 0, and we got to have f of 0 be equal to 10. So we got to deal with the complex conjugate theorem here, because if 1 plus 2i is a 0, then 1 minus 2i, the complex conjugate, must also be a 0. And with these a plus bi form complex numbers, just writing the factors down now is going to get to be a little bit complicated. So let's start setting up our function here, f of x. Our polynomial having -1 as a 0 of multiplicity 2. So x minus a -1 or x plus 1 is a factor. And I need that times itself. I need 2 copies of that factor. That's what multiplicity 2 means. Okay, now here's where it starts becoming just sort of difficult to even write this down, because if 1 minus 2i is a 0, I need to write down the following factor. X minus the quantity 1 plus 2i, and I have to put that in grouping. You can either use double parentheses, or I'm using square brackets just to make them stand out. So what's going to happen here is we're going to end up with 3 terms inside parentheses, and we're going to have to distribute this minus sign in front of the square brackets. It's going to be crucial. The other 0, I'm going to write x. I still have to write minus 1 minus 2i. I can't just write a plus sign there, because it isn't like all the signs just become plus. So I have to write both of these with a minus. Notice that. And then just notice the square bracket grouping. You have to use some sort of double grouping symbols here to make that work. So this is going to be a big mess to multiply out, I admit. And what I'm going to go right ahead and introduce the scaling factor. There's always a chance you don't need it, or that 1 would work, but we're just going to go ahead and put in our a. And where does the a come into play? The a comes into play when we're trying to make f of 0 come out to be 10. So let's see if we can do that. We want f of 0, which would be a times 0 plus 1, 0 plus 1. Now this is 0 minus the square bracket 1 plus 2i, square bracket parentheses, parentheses. So just writing this down, I realize, is a pain. I just put 0 in place of x, and we want f of 0 to come out to be 10. So this is a times, I like the ones, times 1 times 1. But now these complex conjugate parts, the I parts, gets kind of messy, because I have to distribute the minus sign here. So I'm going to have 0 gone, but I have minus 1 minus 2i. And in this factor, I'm going to have minus 1 plus 2i. And to figure out what a is, I got to work this out. And that's like a little algebra problem in itself. So all this is just a, and all this I have to multiply out inside parentheses. This is like a FOIL problem. -1 times -1 is -1 squared, or +1. Outside, I get -2i. Inside, I get a negative times a negative is +2i. And then the L, a negative times positive is -4i squared is what I got. So I have 10 is equal to a times 1 minus 2i plus 2i cancels out, but I have minus 4i squared. So you got to be careful with that I business, right? 10 equals a times 1 minus 4, that's times a -1. There's that I squared. So I actually have 10 equals a times 1 plus 4. Or 10 is equal to a times 5 after all that. Divide both sides by 5. 2 is equal to a. And I got my a constant. Okay. All right, so let's write out the, I think I'm just going to leave it in this line. I'm not going to come up to the side because I need lots of room. So my factored form of f is f of x equals 2 times the x plus 1 times x plus 1, I can just write as x plus 1 squared. I don't have to write those factors out separately. You can, it's not wrong. But now the other two factors are different, and I do have to write them out because they are not identical. 1 plus 2i in the square bracket, x minus square bracket 1 minus 2i. So there's my factored form. And it sort of gives math a bad name, right? It's such a big, ugly mess. We're going to multiply this out. You got to know how to multiply this out. And to work on it now, I'm going to leave the 2x plus 1 for the end, because that's going to be much easier to deal with. I'm going to work on these two parentheses on the end. Now, before I start multiplying, I'm actually going to distribute them, the minus signs here and here. There are a couple different ways you can approach it. You could treat it like a FOIL problem as is, but I'm going to do this, x minus 1 minus 2i, x minus 1, and then I get plus 2i. So it's kind of like each parenthesis ends up with 3 terms in it. So to multiply these guys, I'm going to take x here times each term of the second. So I get x squared minus x plus 2ix. Then I'm going to take -1 times each term. And I'm kind of in a corner here, so I'm just going to come down below. -1 times x is minus x. -1 times -1 is plus 1. -1 times 2i is -2i, all by itself. Then I'm going to take -2i here times each term that follows. So I'm going to get -2ix, and I'm going to get plus 2i, and then I'm going to get minus 4i squared. And all those terms go inside parentheses, so I stretch that out. And it should all go in a line, but I doubled back on myself a little bit. Let's see if we can clean this up a little bit. Now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. I'm combining like terms. I think x squared is by itself. I see a minus x and a minus x. That's going to be minus 2x. I see, I'm going to use red actually. I got a 2ix and a minus 2ix. They're gone. I got a minus 2i and a plus 2i. They're going to be gone. But notice that I do have a plus 1, and I have a minus 4i squared left from that multiplication. Okay, I think every term is accounted for. So, yep, this is kind of intense. Let's try to move on to a new sheet of paper here so I don't squeeze into the corner. And now I still can clean up what's on the end here, because this is a -4 times a -1, which is actually just +4, right? On the end of that parentheses. That -4i squared simplifies to +4. So I got 2 times x plus 1 squared, then I'm recopying x squared minus 2x plus 1 plus 4. And finally, things are getting a little bit better here, because I have x squared minus 2x plus 5. I just get a quadratic out of that messy multiplication on the end. So I just want to kind of have all this appearing on the screen at once to see how we got to this point. Now we're still not done. We still got to multiply this out. We have 2x plus 1, x plus 1 times x squared minus 2x plus 5. But the scary part is over. 2 times this is x squared plus 2x plus 1 times x squared minus 2x plus 5. And 2 times, I'm waiting with the 2, now I got to distribute again, right? So I got x squared times each term that follows. I'm going to get x to the 4th minus 2x cubed plus 5x squared, then 2x, plus 2x cubed minus 4x squared plus 10x. Now I take plus 1 times each one, right? So I'm going to have plus x squared minus 2x plus 5. All that's inside of parentheses. I doubled back because I was running out of room. So I have 2 times x to the 4th. All right, any x cubed terms. It looks like I got minus 2x cubed plus 2x cubed. Okay. I got 5x squared minus 4x squared plus x squared. So that's actually 6x squared minus 4x squared. That's plus 2x squared. And then my x terms are down here. I have 10x minus 2x. That's going to be plus 8x. And then don't forget I got the plus 5 on the end. And all right, now I just distribute the 2. 2x to the 4th plus 4x squared plus 16x plus 10. This is my multiplied out form. Whew. Okay. And all right, so we're done with the problem. And if we had to multiply it out, we had to get to that point there. We got from the factored form, right, through all this work to the multiplied out form. Now this is going on too long, but extra. I just want to say something about the graph, because I think the graph helps us understand what's going on with this polynomial. Okay, we know -1 is the only real 0. We know our y-intercept is at 10. Okay. We know the end behavior is like y equals x to the 4th, so we know at each end the graph is just going upward. And we also know we have a 0 of multiplicity 2 at -1. So the graph does not cross the x-axis there. We know we just sort of have this U turning around shape. It's not obvious to us if there are extra wiggles in this graph. It turns out there aren't. So I think our guess would be to draw something like so. And that's actually very, very accurate. I compared this to Desmos and we get the same thing. So notice that there is one real zero of multiplicity 2. And the multiplicity is kind of revealed in the behavior of the graph at that x-intercept. There's one x-intercept. And there are two complex non-real zeros. And I kind of want to say good riddance. We kind of got them out of the picture a while ago, but that was our 1 plus 2i, 1 minus 2i. And they don't appear anywhere on the graph for whatever reason, but they are buried inside that polynomial, right, when we multiplied that out. All right, so we are through with this section. We're going to move on to a brand new topic, rational functions, next.